All right, so this is going to be part 3 on our quick chart, and this is going to be referring to how I came up with the, I think I call it quick dope number. Um, just off of the bat, just to be clear, this is something that I stumbled upon and I came up with um, by using some other charts, and I noticed some relationships between certain numbers. At the time, I did not have this, but I went out and bought just a cheap Kestrel, and it allowed me to see, 1 yard at a time. And I noticed for quite some time, every 1 yard would kind of equal 0.01 mil. So I noticed there was a relationship. Ultimately, after I had developed this, came up with it, I looked all over the internet because I was like, I'm really onto something here. I couldn't find any videos on YouTube. I looked over the internet. I actually called a couple people that are into, extreme long range shooting and told them about it. I'm like, hey, have you heard anything about this? And they said no. So I'm like really excited that I was onto something. And then I bought this. Well, I actually bought this a little bit after, and then I had it upgraded. And let's see, I haven't really messed with it too much. But under accuracy first, there is this exact formula. So I can't say that I invented it or came up with it. However, I'm still excited that I did stumble upon it on my own. Using accuracy first, there's a thing called Quick Wind, and I did use that from this to develop a part of this other little part of this chart. Anyway, so just to try to make it quick, where I started is that I noticed a relationship between, 400 yards was 1.8, 500 yards, pretty close, about 2.8, 600 yards, 3.8. Excuse me. So I started noticing some sort of relationship between these numbers, and I could never memorize my dope past 400 yards at the max. It would be, I'd memorize it. I could repeat it throughout the day. Go to the range like once a month where I'd actually shoot past that yardage, and I just couldn't memorize it. So I was trying to figure out how to do that. I started off, I think, with 500 yards, and I'm bad at math, but what I ended up doing is taking 500 and subtracting, I think, 276, something along those lines. And I came up with this number. I think at that time it was like 230 something. So then I did 50 minus 2.7 and came up with 23. Anyway, I ended up coming up with some numbers very consistent around 20, 21, 22, 23, depending on where I did. I didn't know what to do with that number, but that's what came up. Eventually, and I don't remember how, I ended up figuring out if you take that number and subtract it from, let's say 22, subtract it from 49, you get 26, essentially. So you get really close to your dope. So what I ended up coming up with was my true dope from 250 yards all the way out to like 900. But I've got 1.9, 2, 2.1, and 2.2. So what I did is I took my true dope and then I made these columns. 1.9, subtracting that from this. And then later on, I was like, okay, I'm onto something. So I wanted to figure out what the error was. So I ended up filling in, where does it say it? Okay, so here's our error, how far out they were. And then this is what the actual number was. Once I figured out everything that I was kind of doing, I started plugging these numbers in, started color coding them. And then I noticed that if I bracket these numbers, I can actually get less than 1 mil of error. Now, it's not necessarily practical in a way, but I'll show you how I came up with the formula to make it practical. So I've only got 250, but if you go less than 250, then we're still kind of does the same thing. But from 250, I highlighted everything that was less than 1 mil error. So from 250 to 290, I can use 1.9 and have less than 1 mil error. From 300, that's what these green boxes are, 300 to 330, which isn't very wide, but I use negative or subtract 2, less than 1 mil of an error. Except you can see from one to the next, I just carried it over so I can switch numbers. But in all these areas, they're all less than 1 mil. So then we jump over to 2.2, which this is why I chose 2.2, because I have the greatest area of accuracy. And so even at these closer ranges from, let's see, we'll call it right here. I think that was 300. I'm still less than 0.2 mils out, but I got a huge area where I'm less than a mil. So that's ultimately why I went with 2.2. Now, once we get out to further ranges, 680, if we switch back to 2.1, we're now less than a mil error. Switch back to 2, between 740 and 780, less than a mil error. And then back to 1.9 from 790 yards to 480, or less than a mil up until we get to 480, and then we're right at, I'm sorry, I keep saying a mil, but 0.1 mil. All these green areas have a less than 0.1 mil or a tenth of a mil error in them. So ultimately, that's how I came up with the quick drop number of 2.2. So what that means is I can take any one of these numbers. Here's my true dope. So let's say 450 yards. I'm going to subtract. I'm going to turn that to 1/100th. So that's what this column is, 4.5. I'm going to subtract 2.2. So 4 minus 2 is going to be 2. And then 5 minus 2 is going to be 3. So that gives us 2.3, which is what that ends up equaling. So there was absolutely some sort of relation that I was able to find. And then I found that I could actually bracket these numbers to make it more accurate. The problem is I'm like, okay, so now that I have this number, how do I memorize or know at what point in time I can use these to make it valuable? Because essentially I just made this cool chart. And I'm like, well, I have a Kestrel, so why would I use this? Well, that's what our quick chart is for, and I'll get into that in the next video. I appreciate you guys for watching. Hopefully this is pretty simple. You understood it. Thank you.